Rahim. Inshallah, today in this session I'm going to speak how to calculate slope in numerical transformer differential relay. But before I'm going to speak how to calculate the slope, we need first to understand why you need the slope. Why you need to create the slope in transformer differential relay. Simply, we need the slope in transformer differential relay because in the transformer differential relay we have some issue or some challenge or some problem can lead the transformer differential relay to mal-operate or unnecessary operate. Like example, the magnetizing current. During the magnetizing current, the transformer differential relay could be get some differential current, and that differential current can lead the transformer differential relay to mal-operate. And as you know, the magnetizing current is the normal condition in power transformer. Also the CT error. The CT error and the current transformer, it is the input of the transformer differential relay, and due to that error of the current transformer, also the transformer differential relay will get some differential current and also could be mal-operate. And also we have tap changer leakage current. During changing the tap changer, like on load tap changer in power transformer, during changing the tap changer will get some leakage current, and that leakage current will get some differential current in transformer differential relay, and then the transformer differential relay also could be operate. Also the CT saturation. During CT saturation means though there are no current will flow through the secondary side of the current transformer to the transformer differential relay. So 100% the transformer differential that case will get some differential current, and that differential current will lead the transformer differential relay to mal-operate. Then we have also the second harmonic and the fifth harmonic. It is the inrush current and overexcitation. During these cases also transformer differential relay will get some differential current and also could be mal-operate. And all these cases, it is not real fault. It is not real fault. Okay? So we don't want to this transformer differential relay to trip. So that's why we need to create the slope in transformer differential relay. Okay? So now how to draw the slope in transformer differential relay. Simply we'll draw the slope like this. Here in x-axis here we have something called I restraint. Okay? And in y-axis here we have I differential. Okay? So we'll draw first line like this. Okay? Then we'll draw the slope 1, then slope 2, then we have this line. Okay? So this way we will draw the slope, and all this, the point of the slope, we need to calculate it. Okay? The down area here below the slope, this we call it restraint area or non-trip area or blockade area. Means the transformer differential relay should not operate. And above the slope, this is the trip area. That means any point above this the slope here, the transformer differential relay should operate. Okay? So now let's calculate the slope. I will take the real example. I have here the setting, that real example for 7UT 613. It is Siemens relay, transformer differential relay. And the client, they give me this setting, they give me minimum differential current. Okay? Minimum differential current, they give me how much? 0.25, and high set differential, I differential 7. Also they give me slope 1, it is 20%, slope 2 70%, and they give me also slope 1 in point will be equal to 2.5. Okay, also they give me the second harmonic and the fifth harmonic. Second harmonic 50% and fifth harmonic is 30%. So they give me this setting. It is a real example for last transformer differential relay I tested. Now let's implement the setting here in the graph. Okay, let's implement the setting in the graph here. First, they give me minimum differential current. It is 0.25. This is I differential in y-axis. So this point it is 0.25. Okay. So this point is 0.25, and you give me high set differential current 7. Okay, they give me slope 1, it is 20%. This slope 1 equal 20%, and slope 2 it is 70%. Okay, also they give me slope 1 end point. This the slope 1 and this the end point, this one. So they give me here 2.5. Okay, so now I need to calculate unknown point. Some point here I need to calculate it. So first I need to calculate this point here, this one. Also I need to calculate this point. Also I need to calculate this point. So 3 points here I need to calculate it to draw the slope. Okay, so here, as you know, the point here we need, it is x and y. Okay, x and y. So in this point here, the x is 0 and the y also 0. So this one I will name it like x2, this x3, and this x4. Okay, and this y2, y3, and this y4. Clear? So now let's calculate the first point, this point. Okay, I need to calculate this point. So we can calculate it simply by using the slope equation. So the slope will be equal what? Delta y by delta x. Okay, and delta y what's equal? It is mean y2 minus y1 and x2 minus x1. So the slope 1 is give me how much? 0.2. y2 it is 0.25 minus y1 it is 0, and x2 it is unknown, this x2, and x1 is what? 0. Okay, so cross multiplication will be equal 0.2 x2 will be equal 0.25. Now we can get the x2 will be equal 0.25 divided by 0.2. So the x2 will be equal how much? Let's calculate the x2. 0.25 divided by 0.2. It is 1.25. So this point, this one I found it. It is 1.25. So this the first point here in the slope here I found it. It is 1.25, and the y here we have 0.25. And the same procedure I will calculate the remaining point. Example, I will calculate now this point, the second point here, y3. So we'll say same things. Slope will be equal what? y3 minus y2 and x3 minus x2. And the slope here in this point, this here, it is from 0.2. Okay, and y3 it is unknown. This y3 minus y2 how much? 0.25. Okay, and x3 it is 2.5, and x2 it is 1.25. Okay, so y3 minus 0.25 will be equal, so 2.5 minus 1.25 multiplied by 0.2 will be equal 0.5. It will be 0.25. Then this one will go in another side in the positive, will be y3 will be equal what? 0.5. So this y3, this one I found it, it is 0.5. Okay, so the last point here, this point I need to calculate the last point here. I will remove this one. Okay, and this point it is belong to what? Slope 2. So slope 2 will be equal what? y4 minus y3 and x4 minus x3. Okay, slope 2 is 0.7, y4 how much? 7 minus 0.5, and x4 it is unknown, I need to calculate it, then minus 2.5. Okay, so I will say like this one 0.7 multiply by x4 minus 0.7 multiply 2.5, it is 1.75. Okay, then 7 minus 0.5 it is 6.5. Okay, then this I will shift it another side in the positive, so 6.5 plus 1.75 will be equal how much? Will be equal like this one 0.7 x4 we say will be equal 8.25, so x4 will be equal 8.25 divided by 0.7 will be equal how much? Will be equal 11.78. So this point here I found it is 11.78, and so this point will be 11.78, and here will be 7. Okay, and this point we have here 2.5, and here we have 0.5. So I found all the point in the slope. So simply now we need to enter the point in the test kit to draw the slope. If you use CMC, if you use the like example VIPCO AMT205, just you need to enter this setting and click to the draw custom, then he immediately will draw the slope for you. But as a protection engineer, we need to understand how to calculate the slope and how to implement the slope in the test kit. Also, before I'm going to test the transformer differential, we need to ensure the eye restraint calculation or eye restraint formula, because different manufacturers like ABB or Siemens or Cell Relay, they have own equation for eye restraint. So before I'm going to test the transformer differential relay, we need to check the manual of the relay, then I need to check the eye restraint formula, then also the K constant factor, because like example in ABB constant factor is 2, but in the Siemens it is 1. So if you entering the wrong restraint formula, means the transformer differential relay will not get accurate or not get the exact result, or the test will not pass. Okay, then in the transformer or in the slope, we need also to test testing. Like example, we need to test the shot test. As you know, in shot test, just I will give some point below the curve here, below the slope, and some point above the slope. And any point above the slope means I will get what? Trip. And the point down the slope or down the slope should not trip. The second test, it is search test. In the search test, we have here like boundary. He will check the line or the search of the slope. Okay, so those two testing I need to do for the slope. Mostly it is shot test and the search test and testing. So now I think you get idea how to calculate the slope and how to test the slope. Okay, thank you so much.